given a signal. So I would like you to sketch xn u1 minus n. Okay. So do you know how to sketch this? Okay, if just do a quick review here. This is a discrete time signal. You know, it's defined to be 1 for n greater than or equals to 1, right? It's 0 for n is less than 1. And this looks like this. This is 0, 1. Again, I would. Okay, this is use of n. And you know the use of minus n. For use of minus n, you can just flip this around 0. It's going the other way, right? Are you guys listening, following?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Again,
Yes, sir.
I would like to stress again, please follow very carefully from now on. Okay, if you listen very carefully, n is equals to is 1 for n greater than or equals to minus 1. 0 for n is less than minus 1. Right? So it's going, you're going to get, this is minus 1, 0, 1, 2, 3, 4. Somebody got still the mic on. Someone please mute all your mics. Is this okay? Do you guys follow so far?
Yes. Yes.
Then what about minus n plus 1? How do you do that? All you do is you just flip around. Flip un plus 1 around the y-axis. So you're going to get well, there's another way to do this. You first, or you can just plot. Another way, okay, if this is the un, say for example, this is un. Okay. un plus 1 will result in the signals moving one step to the left, correct? Right? Because from here, you will, when you solve, you get n equals to minus 1. So it's going to move one step to the left. Okay.
Okay. Okay.
Okay, now we look u minus n is going to be like this, correct? Okay, let's say if I add 1, u minus n plus 1, it's going to move the signal to the right. See the difference? When you add 1 to the u n plus 1, it moves to the left. But you add 1 when u minus n plus 1, it will move the signals to the right. See the difference? So make sure you guys are very fluent in this. So now you see the signal here. With this understanding, so this is x of n. And then you want to multiply that by u1 minus n, which is right here. So now you can see what happens. We multiply them. So from here onwards is 0, right? 0 from here onwards, and it's also 0 here. 0. But this part here is not 0, it's 1. Continue to go on. If you multiply these guys together, so when n is minus 3, we get 3. And that is xn u1 minus n. Please go ahead and take a look at it and see if this makes sense to you. When you sketch, be very careful. Sketch, make sure you put, you number them correctly. 3, 2, 1. Xn multiplied by un plus 2 minus un. What this part is telling you, you have a signal that's starting, you have signal u that's starting at minus 2. Okay. Yeah, this is a u n plus 2 minus 2 minus 1 and so forth. Then you subtract a signal that's starting at and then you subtract a signal that starts at n equals to 0. Okay, a small mistake here. It's not 0. Continuously goes. Okay, now un plus 2, un plus 2 subtract u n. Okay, this is called this use of n. You're going to end up getting what? How many? So equals to all of them.
Negative 1, 0. Negative 1, 0.
No, that's a mistake we make. 0 also you have. They will cancel each other. You cancel each other, isn't it? At 0.
Yes, sir. Yes, sir.
So you have to be careful. It's not like this is very important. It is not like, for example, in the continuous time signal, it's different. In the continuous time signal, when you have u n plus 2, sorry, u continuous time signal is t, u t plus 2 minus u of t. It's usually going from 2 to 1 to going from 0 to 2, isn't it? Sorry, minus 2 to 0. Going from minus 2 to 0. Am I right?
Yeah.
Yes, sir.
Yeah.
Yes, sir.
But look here. The 0, there's no 0 here. It's 0. So don't make that mistake. In the discrete time signal, you have to sketch it out and see. So in continuous time signal, you have you have minus 2, minus 1, and 0. For discrete time signal, you only have minus 2 and 1, minus 1. Signal exists only at minus 2 and 1. At continuous time signal exists from minus 2 to 0. Okay. Where did you guys lose me? I don't know. Did you guys were following this part here, number 2?
Yes.
Okay, did I complete number
Yes.
2?
We didn't reach until the left part.
We didn't reach until the
The answer part.
Left
Okay.
part. The answer part.
2 1 and 1, sir. The left part 2
Uh-huh.
1 2 1
So all
and
I'm
1,
saying
sir.
is like this part here. All I was telling. All I was saying like this part here. This part, you can put this separately here. This for continuous time. This part here is u n plus 2 minus un. Okay. Then I was saying next, since signals that you multiply by xn, so the signal that you multiply by xn is xn u n plus 2 okay, because we have this signal here. This is like a filtering. When this signal get multiplied to xn, only the signals at -2 and -1 will be multiplied. So in that case, only these two signals, that is at -2 and -1, appears here, which is -1 and -2. That's what I was saying. For discrete time signal, delta n, for discrete time signal delta n is defined to be 1 when n equals to 0 in this case, and 0 when n is not equals to 0. Is 1 when n equals to 1, is 0 when n is not equals to 1. So this delta n minus 1 is time shifted by 1. Okay? If I sketch this signal, then you will have just one signal when n equals to 1. Elsewhere is 0. So the amplitude of this signal is 1. You'll only filter this out. Okay. The rest will go to 0. So therefore the output Okay, that's the answer. Which is equals to, for example, in this case, when x is 1, you put 1 here. And what is the value of x when n equals to 1? It's simply 1. Okay, that's 1 right here. Okay. 6. You see what you get? All this will go to 0, isn't it? When you subtract, all this will be cancelled. And what remains is only one signal at 5. So this is where I'm asking you to be very careful. Okay, going on. These are 0. Then next, I add 2. When I add 2, I'm going to pull the series to the right by 2. Okay, so all these are 10. 10, you know, all of them are amplitude 10. So just can put a 10 in one place is sufficient to show the amplitude. So next one, -5 and -2. -5 and -2. Let me move this down a little bit. Okay, let me plot UN first. Let's say if I'm plotting UN. Call this like 5, amplitude 5. So this is like, forgot to put 10 here. It's supposed to have been a 10. So I'm just plotting 5 UN, assuming I'm plotting 5 UN. So you know how to do that, right?
Yes.
Okay,
Yes.
now I'm going to -2. So I'm going to -2. -2, like if you solve, and we're going to give you n equals to 2, right? Correct? Over here also. So then you're going to
Yes.
shift the entire thing to 2, to the right. So let me do that. Okay, this was 0, 1, 2, 3, and so forth. So I'm going to just delete It's just starting to rain here also. So the signal get shifted to the right by 2. So this is like 0 here, 0. The same thing here, you know, like when you solve for here, for example, minus n plus 2 is equal to, right, 2, 1, 0, minus 1, minus 2, minus 3.
Until -7, right? Until -7,
Beg
right?
pardon?
Until
Beg pardon?
-7, is it? Until -7, is
So
it?
this is going up to infinity. You see, infinity. Going to infinity,
Okay.
in the negative direction. Where did you get the -7 from? Why you are saying -7?
Because I thought the 10. Because I thought the 10 dot to the left. 10 dot to the
So
left.
10 is the amplitude.
Okay. Okay.
Okay, what's outside the U? If you look at this carefully, like this is like amplitude. Amplitude. This is what's inside here is time shift.
Okay. Okay.
So you have a minus sign on the end, that is going to be telling you either you invert the signal to the left or right, invert around the axis, about the vertical axis. If minus, then your signal will go to the left. If plus, then the signal will go to the right. The time shift is not the end, sorry. The time shift is this 2 here. Okay. And the end is just inverting. Minus means the signals will grow to the left direction, go to the left direction. If plus n, it will go to the right direction. Any more questions?
Master.
Yes.
If negative n is have to flip it over. If negative n is have to flip it
What is
over.
it? Say that again.
If negative n have to flip over. If negative n have to flip over the.
You can do either way. You can either flip over or you can do this way.
Oh, okay, sir.
Sir,
Okay, sir.
then how the amplitude? Then how the amplitude affect in this
The
case?
amplitude is you just the now right now this is 10, right? This amplitude right here is 10, isn't it? Okay.
Yes.
That's the
Yes.
how tall the signal is going to be. Okay, 10 this case, right? And in this case, the signal amplitude is 5. So the length, the vertical, the height of the signal is 5. That's the strength of the signal. Minus n is a signal that's going this way to the u minus n. This signal is a signal with the amplitude 1. So it is going to go okay in the negative direction. -1, 0, -2, -3, and so on. So if let's say if I make it plus, then use of n, now plus n, now you just flip around the vertical axis. For example, if we call this axis xn, use of is u minus n. So xn is use of n, function of un, use of n. So now in this case, you just flip the signal around the vertical axis. Now we're going to the right. Just examples. We can do in a couple of ways. I also showed you earlier in the previous lectures that you can draw either way. See which one is convenient for you, but stick to the easiest way. You have to sit down and then design your own method, which way you want to do, and stick to one method. You can flip first. A flip means like it's not really flipping, like this is defined as n is equals to 1, sorry, is 1 when n is less than or equals to 0. 0 when n is greater than 0. That's how it's defined. So this is defined to be 1 for n is greater or equal to 0, and 0 for n is less than 0. Just a quick review. Who's still, anybody still confused? I'm going to, it's cluttering the place. Okay. Okay, the red one, subtract the blue one. Can you guys see? The red one, subtract the blue one is going to give you okay, if you look at okay, if you guys look at this point here, you start from here as your, if you look at 2, when n equals to 2, 10 minus 2 is 5. Okay, go ahead and draw 5. So this is 5. Okay, at 3, 4, 5, 6, and so on, you're going to have 0 minus, when n equals to 3, 4, 5, and so on, you're going to have 0 minus, like this is amplitude phi, right? This is amplitude 5. At 3, 0 minus 5 is
Minus 5, sir.
10, 10. All right, the next one. Okay, we were doing this halfway, right, just now? Okay. Now we're going to subtract one another. And we also note that you're going to subtract, you're ready to subtract them, but please note that you have something here going on. When the n increases, you put this in red. This is the amplitude. You're subtracting them, and then you're going to multiply by 0.1 times, sorry, 0.1 to the power of n. So this is amplitude. Amplitude as n becomes bigger, so it's going to make the signal go like this. It's going to attenuate the signal, okay? As n becomes bigger. That's what it's going to do. Okay, now we try to subtract un minus un minus 5. So when n equal to 0, okay, when n is equal to 0, right here, when n is equal to 0, the use of n is 1. Un minus 5 is 0, right?
Yes.
So 1 minus 0
Yes.
is 1,
Yes,
isn't
1.
it?
1.
1. So this is my xn. Xn is 0. 0.1 to the power of 0 is 1, isn't it? Okay, next, at n equals to 1, again, 1 minus 0 is going to give you 1, right? Then don't forget about 0.1 to the power of 1 is how much?
0.1.
Then you have to put 0.1. 0.1. So when n is 2, again you get 1 minus 0, 1. Then the n increase to 2. 0.1 to the power of 2 is 0.0. 0.01. Similarly, as you go on, so it's going to be until here 0.01. And then do we have some more? Yes, we also have, this is going up to infinity. So when n equals to 4, then you're going to also get another amplitude, which is 0.001. 1 to the power of 4 multiplied by 1. Okay, any other questions? Xn minus 3. You're going to move the signal to the right by 3. If you're going to move right by 3, that means you're going to add everything by 3, right? 0 part of the signals. Okay, so You're just shifting the time by 3. So we're adding everything by 3. If you add everything by 3, then you get what? This becomes 6, isn't it? 6, 5, and then this becomes 7, 8, 4, and then 4, this is 4, and then this is 3, this is 2, 1, and 0. And just move the axis to 0. Please make sure that you mark all the amplitudes correctly. This is -1, this is -3, -3. So this is -3, -1, and it's equals to x 3 minus n. X3 minus n. Just now it was n minus 3, now 3 minus n. Okay, let's start again. Whatever that's on the left will come to the right. Whatever that's on the right will go to the left. Next, I put everything that's on the right to the left. This remains here. By 3. Okay, next, what you need to do, we already flipped it. Now you have to add 3. Add 3, right? So when you add 3, let's say you are starting from, don't worry about the 0. So on the left and right. In the middle 0, maybe we care about it. We just start from the signal here. Then we start here, non-zero signal +3, +3, then +3 here. The middle also +3. You go ahead and +3. This is a 0 is okay. Plus in the middle is okay. You can just add them. So what will happen when you +3? This point here, right here, this point here becomes -3 +3 becomes 0. Okay, so that is your starting point. That is a starting point. And you just can just add 3. Then you can make this 0, 0, color. 0, not 0 there, I mean 0 here. 0, 1, 2, 3, 4, 5, 6, 7. There, that means you're scaling the signal by 3. That means you dividing, just divide all the time by 3. Yeah, really don't. Okay, so you just divide all the time by 3. You divide the time by 3, and then only plot the integers. Wherever there's no integers, just ignore it. Yn looks at only every third value. That means time scale, plot only integers. So you time scaled in, that is divide by 3, plot only integers. Okay, therefore you're just, let me copy this over here. So now 4 divided by 3 is not an integer, so don't worry about all these things. Okay, don't worry about this, because these are not integer. Okay, this is an integer, you keep it. This is not an integer, remove it. This is not an integer, remove it. 0 is an integer, you keep it. And then not an integer, remove it. Divided by 3 is not an integer because -2 divided by 3 is a fraction. Now this is an integer, keep it. So when you remove things, you just remove the others that are not integers. So you're going to have -1, -1, 0, and 1. Okay. If you want to move them to -1 is here. Okay, this means earlier I already plot this for you. So this really means you have a signal that's going to the left, starting from here, 3, 2, 1. Right?
Yes.
Same as xn. Okay. Any question? Okay, that's the last one. Do this first. Or you want to do the other way also can, I think. I don't know. You can try. First, we time shift by 2. When you time shift by 2, everything is going to be shifted by, like, for example, you're going to be adding 2 to all. Okay, this is adding to the time, not to the amplitude. Adding to the time. Plus 2, plus 2, plus 2. So in that case, this become 5, 4, 3, 5, 4, 3, 2, 2, 1, 0, -1, and 0. You can go ahead and move this axis over to 0. Okay, this is xn minus 2. -1, -3. Okay, that's it. So delta function is going to be appearing here. Just at n equals to 2, amplitude is 1. Okay, so that is delta function definition. According to the definition of the delta function, you're going to have a spike when n equals to 2. Now you can see very clearly the delta function is just like a filter. We multiply with xn minus 2, it's just going to filter this out. So you're going to get 1 here, amplitude is 1, and then amplitude over here is also 1. So you're going to end up getting a 1 at n equals to 2. And that's going to be n x n minus 2 delta n minus 2. Xn minus 1 delta n minus 3. Okay, that's all. I will see you all guys tomorrow then.